Lesson 50, 9-2, simplifying rational expressions. We're going to split 9-2 up in 2 days. So lesson 50 is going to deal with basically finding the excluded values of rational functions again. You did that prior on lesson 49 to find out basically your denominator cannot be equal to 0. So your rational expression here, your denominator, whatever that polynomial is on the bottom, it cannot be 0. So in order to figure out your excluded values again, what you would do is you'd take, in example 1, your denominator and set it equal to 0. When you set it equal to 0, basically you're solving for n, and what n has to be in order to make your denominator 0. That's why you set it equal to 0. So solve for n. Divide both sides by 18. When you divide both sides by 18, you wind up with n squared equals 0. You need to find out what n is. In order to get rid of a square, you would use the square root. So I would square root both sides, and when I square root both sides, I get n equals 0. So therefore, n cannot be 0. The way to double check it is actually plug in what you found out in for that denominator. So if I put in 0 for n, 0 squared is 0, 0 times 18 is 0. Again, you can't have that denominator 0 divide by 0 error. Example 2, again take your denominator, set it equal to 0. When you set it equal to 0 here, you'll notice that you'll want to do some factoring, and in this case you'll want to factor out your greatest common factor. Numerically, you can factor out a 2 out of both terms and a v out of both terms. So I'm going to factor out a 2v. When I factor out a 2v, I'm left with v minus 1, and then again set it equal to 0. So if you did the distributive property, 2v times v is 2v squared. 2v times negative 1 is negative 2v. Saying the same thing. Now that you've factored it down, you're going to go ahead and set both these terms. They both have a variable, so you can solve for v in both of them. So set 2v equal to 0 and v minus 1 equal to 0. When you solve your problems here again, you'll divide by 2 on both sides. 0 divided by 2 is 0. And here you'd add 1 to both sides, and you'd find out v is 1. So in this, v cannot be 0, and it cannot be 1. Just proof, put it back into your equation. Put in 0 for v. 0 squared is 0 times 2 is 0. Negative 2 times 0 is 0. So 0 take away 0 is 0. So that's why 0 is an excluded value. If you substitute in 1, 1 squared is 1. 1 times 2 is 2. Over here you have negative 2 times 1 is negative 2. So 2 minus 2 is 0. Again, can't have that denominator 0. Those are your excluded values. In examples 3 and 4, we're going to be solving or simplifying each of the rational expressions. What it states up here is BC divided by CA. You have B is the same as B times A and C times A, which is equivalent to B divided by C. Basically what happened is they were able to eliminate your A's, and you can kind of determine what happens over here. We factored out a 3 and we factored out a 4. We're able to get rid of the x minus 3's. Down in example 3, set it equal to a fraction here. So I found out some of the prime numbers here. The numerator is really saying 3 times 5 times a times a times a. Your denominator is really saying 3 times 7 times a. So your next process would be to go ahead and eliminate what you can eliminate. Well, we can eliminate a 3 out of the numerator, a 3 out of the denominator, an a off the numerator, an a off the denominator. On the top you'd have 5 times a, or 5a squared, and the denominator would be 7. This would be your simplified expression. Example 4, same approach. Don't forget the negative sign here, so I went ahead and put in my negative right away. Here's my fraction bar. 6k is 2 times 3 times k. The bottom is 3 times 9. Now I could break this down into 3 times 3, but what I'm going to have to do eventually again is multiply the 3 by 3 because there would be both of those 3's would be left over. So what I would go ahead and do is get rid of what I can, get a 3 off the numerator, a 3 off the denominator, take out a k, and your numerator you'd be left with 2, your denominator 9k. Again, don't forget the negative sign. Here it is, all the way across that problem there. This will conclude lesson 59.2, simplifying rational expressions.